Okay. Similarly with cosine and the inverse. You've seen this before in your calculators. Now we're going to talk about arc cosine of x. And same exact thing, you're going to ask yourself what angle measurement has a cosine of whatever value is being evaluated. Now very similarly, you're going to go ahead, and I made the mistake. I'm going to go ahead and white that out because these should be our y's. That's what we are evaluating. So this should be y is equal to for all of these down here. And again, you're asking yourself, here we're talking about the inverse cosine function and we're talking about the y values. Again, the y values are your range. And the range of my inverse cosine function is from 0 to pi. So again, we're talking about in quadrant 1 and in quadrant 2. So then I'm asking myself, what angle gives me a cosine of 1/2? Very similar as above, it's pi over 3. And then you'll see, okay, it's really repetitive. And these are just going to be the same exact solutions. Okay. All right, then last but not least, we have tangent. Tangent, you remember, we don't have to graph the whole entire thing, but tangent does start in the middle, and then it goes from negative pi over 2 to pi over 2. If I were to keep going, okay, right, all these pi over 2's have, oops, an asymptote. And then we have my graph of tangent. Okay, so this one would also not be a one-to-one function. So then the inverse must not be a function. Okay. And again, you're asking yourself, okay, what values of x gives me a tangent of 1? This is when we have pi over 4. And I'm going to go ahead and condense it to pi k, where k is in the set of my integers. Tangent's kind of nice because when we restrict it, we're just going to go ahead and pull this full graph of my tangent. So I am going to have negative pi over 2, pi over 2. And those are my asymptotes. And then there is my tangent function. Okay, my domain is from, this one is tricky, right? Since we have those asymptotes, the negative pi over 2 and pi over 2, they are not included. So these are going to be soft brackets. I can make note of that. Soft bracket. Is that how you spell bracket? I don't know. I don't think so, but whatever. Okay, and then the range looks like we're going from negative infinity to infinity. Cool. So kind of like with the sine and cosine function, I'm really going to go and flip these guys. So instead of, we're going to go from a pi over 2 to a negative pi over 2. And again, this is where my asymptotes are. Okay, in my restricted tangent function, right, we're going towards negative infinity when we're going towards a negative pi over 2. So that means I'm still going to go from a negative infinity when we're at negative pi over 2. And then I'm going to go towards infinity when we're heading towards a pi over 2. So there's my inverse tangent function. These guys just switch, so I'm going from negative infinity to infinity. And my range is, again, these pi over 2's are not included, so I do have my soft brackets. Okay. Now when we're talking about tangent, if I look over here, right here's pi over 2, here's a negative pi over 2. Very similar to sine, we're only going to focus on quadrants 1 and 4. Okay, so my domain is from a negative pi over 2 to a pi over 2. Again, my pi over 2s are not included, but we are in quadrant 1 and we are in quadrant 4. So you're going to ask yourself, okay, what values of x gives me a tangent of 1? This is just my pi over 4. And then what values of x give me a tangent of 0? This is just 0. What values of x give me a tangent of a negative radical 3 over 3? Right, this is my negative of tangent. This is going to be a negative pi over 6. And then I have what values of x gives me a tangent of radical 3. This is just pi over 3. Okay. Again, very similar with the notation of everything. We're going to be talking about arctangent of x. And again, you're asking yourself, what angle measurement gives me a tangent of blah, blah, blah. So if I'm looking at my inverse tangent function, right? The same thing again. Sorry, guys. I messed that up. That was my bad. We're not evaluating x, we're evaluating y. So you can go ahead and write that in. So again, we are talking about your y values. The y values, we're talking about the range, and the range of my inverse trig function for tangent is from a negative pi over 2 to a positive pi over 2. So again, you're talking about quadrants 1 and in quadrant 4. So for the first example, you're thinking what angle measurement whose tangent is 1? You're going to say pi over 4. Second one, what angle measurement whose tangent is 0? This is just 0. The third one, what angle measurement gives me a tangent of a negative radical 3 over 3? This is a negative pi over 6. And then the last one, what angle measurement gives me a tangent of radical 3? This is just pi over 3. Okay. So we see the correlation between the restricted sign, any of them actually, restricted cosine, sine, tangent function, and the inverse of them as well. Okay. So the last page is just a nice little chart to go ahead and just summarize what we were talking about in today's class. So if I were to go ahead and look back at it, right, the domain of a sine function is from a negative pi over 2 to a positive pi over 2. And then the range, it looks like it's from negative 1 to 1. Right? And then again, we're only focusing on quadrants 1 and quadrants 4. When we're talking about my restricted sine function. Okay, if I were to go ahead and look at the inverse sine function, this is when it switches, so we're going to be evaluating the domain from negative 1 to 1, and the range is from a negative pi over 2 to a positive pi over 2. Okay, again, we're evaluating my y values, so we are looking at the range for my inverse functions. And again, we see that we're talking about in quadrant 1 and in quadrant 2. So quadrant 1, and quadrant 4. I meant quadrant 4. Right, and then my cosine, my original cosine function, we're coming from a 0 to pi for my domain. My range is from negative 1 to 1. The domain for this one is in quadrant 1 and in quadrant 2. And then the inverse just again switches, so our domain is negative 1 to 1. My range is 0 to pi. And again, it looks like we are evaluating my y values of my inverse function in quadrants 1 and in, quadrant 2. Okay, and last but not least, we're talking about my tangent function. Remember, in tangent, this is when we're talking about soft brackets, so we're from a negative pi over 2 to a positive pi over 2. where pi over 2's are not included. And then my range is going from negative infinity to infinity. And again, we're talking about quadrant 1 and quadrant 4. Okay, the domain for my inverse tangent function is negative infinity to infinity, and my range is from a negative pi over 2 to a positive pi over 2. And again, very similar to my sine function, we're talking about quadrant 1 and in quadrant 4. Okay, so the only odd one out would be my cosine function, where we're evaluating quadrant 1 and quadrant 2. Right, and that's it.